So welcome to s.mathguru classes. Now we consider properties of Jacobian. Last class we solved some problems about Jacobians. The property 1 given, first property, if u and v are the functions of x and y, then del uv by del xy into del xy by del uv equal to 1. That means this cancel, ultimately you get 1. This is the property 1. First property. Second property. If u and uv are functions of rs, u equal to rs, r something rns, v also rns, where rs are functions of xy, then del uv del xy equal to del uv del rs del xy. That means in adding these two, this cancel, del uv del xy, we get this one. Just adding these two, cancelling these two, ultimately we get this one. So these two properties we consider. First property, using by first property we solve some problems, but next today we consider this property also. Consider one problem. The problem is that find the value of the Jacobian del uv by del r theta where u equal to x square minus y square, b equal to 2xy, and x equal to r cos theta, y equal to r sin theta. These are the values given. We have to find Jacobian del uv del r theta. Now first we consider u and v. U equal to x square minus y square and v equal to 2xy. Del u del x del x, x square minus y square, this is twice x minus 0, this one twice x. Del u del y del y, x square minus y square, 0 minus twice y minus twice y. Del v del x del x, 2xy, 2y into 1, del x 1. Del v del y, this is del v del y, this is del y, 2xy, this is twice x. Twice x into 1, twice x. This one we get. So we get this. Now del uv del xy, what will be the result? By definition of Jacobian, del u del x del v del y, del u del y del v del x del v del y, this one, and the value of del u del x is twice x, and this one minus twice y, and del v del x, this is twice y, this is twice x. If we expand this, then this will be 4x square plus 4y square, this into this into this, 4 common, x square plus y square. Again x given r cos theta, y means r sin theta. So if we putting the value 4, x means r cos theta, y means r sin theta, this whole square, and this is r square cos square, r square sin square. Taking r square common, we get cos square theta plus sin square theta, 4r square into 1. We know this formula, cos square theta sin square theta is 1. From at the very beginning we know this formula. Whatever be the other formula, whether you know or don't know, but we know sin square theta cos square theta is 1. So we get 4r square. We get this answer. So what we get, del u comma v del xy. I want to write the result here. Del u comma v del xy, this equal to we get 4r square. We get this is the result. Next, we have to find this. Since x equal to r cos theta, y equal to r sin theta, these are given. So del x del r del r r cos theta, and this is del r 1, we get cos theta. Del x del theta del theta r cos theta, r remains same, del theta cos theta means minus sin theta. So this is minus r sin theta we get. Next, del y del r del r sin theta. So this is sin theta, del r 1. Del y del theta, this is del theta r sin theta, this is r cos theta we get. So we get r cos theta. Now our requirement, now we have to find del xy del r theta. This equal to, by definition of Jacobian, del x del r del x del theta del y del r del y del theta. We get this one. And putting the values, del x del r, we get cos theta, del x del theta, we get minus r sin theta, del y del r, this is sin theta, del y del theta r cos theta. We get this one. So this will be, if we multiply, expand this determinant, r cos square theta plus r sin square theta. This into this minus this into this, minus plus, we get this. So r common, we get cos square theta plus sin square theta. R into 1 we get. So therefore what we get, del xy del r theta, this equal to r we get. Now our requirement, this Jacobian of this. Now del uv del r theta, by using property 2, we get del uv del xy del r theta, this one. Del uv del xy, this value is 4r square, and del xy del r theta, this is r. Then we get 4r cube, and this is our final answer. Answer is Jacobian of del uv del r theta, answer is 4r cube. This is the answer. Consider another problem. If x equal to root over vw, y equal to root over wu, and z equal to uv root over. and u given r sin theta cos phi, v equal to r sin theta sin phi, and w equal r cos theta. Calculate del xyz by del r theta phi. This one we have to find. Now first we consider xyz, x given root over vw. So del x del u del u root over vw, this will be 0 because it differentiates partially with respect to u. Del x del v del v of root over vw, so this is 1 by 2 root vw into w into 1, because we know this formula ddx of root x equal to 1 by 2 root x. Here directly write this result, and del v vw means v is 1 w, and again we know x by root x means root x, so w by root w equal to root w by 2 root v. We can write root v root w, w by root w equal to root w. Del x del w del w, x means root over vw. This is similarly we get this same vw, and this is v into 1 root v to root w, we get this one root v by this. So x is over. Next we consider y equal to root over wu, del y del u del u root over wu. This is 1 by 2 root over wu into w, and w by root w, this is root w by 2 root u. We get this del y del v, this one del y del v, then this will be del v y means wu, 1 by 2 root wu into this is v and wu, this will be 0, this is 0. Del y del w, this is del w root u, 1 by 2 root u wu into u, so root u by 2 root w, we get this one. Next z equal to given root over uv. Now we find del z del u del u root over uv, 1 by 2 root over uv, and this is v root v by 2 root u, this one del z del v del v, and z means root over uv, 1 by 2 root over uv into u, so this is root u by 2 root v, and del z del w del w root over uv, this is 0 because we differentiate partially with respect to w, and this is uv is constant 0. Now first we have to find del xyz by del UV and by definition of Jacobian, del x del u del x del v del x del w del y del u del y del v del y del w del z del u del z del v del z del w. This is by definition of Jacobian, we get this one. Now putting the respective values, del x del u, this is 0, we get 0, and del x del v, we get root w by twice v, and del x del w, this is root v by 2 root w, we get this one. Next, second row, del y del u del u, this is root over root w by 2 root u, and this value is 0. And next one, root u by 2 root w, and del z del u, this is root v by 2 root u, and this is root u by 2 root v, and this one 0 we get. Now if we expand this one, 1 by 2 1 by 2, from this 1 by 2 common, here also 1 by 2 common, and this row we get 1 by 2 common. So we get 1 by 2 1 by 2 1 by 2. Next we get 0 w by root v by root w, and this will be root w by root u, 0 root u by root w, and this is root v by root u by root v, this one 0, we get this. Now this is 1 by 8, and if we expand this determinant, if we expand, so we expand this in this way, then first number is 0 into something is 0, so no need to write this. Next, second one is minus w by root v, then this cancel, this into this 0, this into this, we get this. This is 0 minus root v by root u into root u by root w, we get this. And the last one is root v by root w. This equal to this cancel, this into this minus this into this. So this will be root over w by root over u into root over u by root over v. This one we get root over u so root w root u into root u root v, we get this one. Now this is 1 by 8, and u cancel, this into this, we get w root v into root v root w plus root v root w, this u cancel, root w by root v, and this will be 1 by 8, this is cancel, we get 2 by 8, this will be 1 by 4. So what we get, therefore del xy z del uvw, this equal to we get 1 by 4. Now again u equal to r sin theta cos phi. So del u del r del r sin theta cos phi, and del r 1, this is sin theta cos phi we get. Del u del theta u r sin theta cos phi. So r cos phi constant, this is r cos theta cos phi we get. Next del u del phi del phi u means r sin theta cos phi, we differentiate partially with respect to phi, then cos phi means minus sin phi, minus r sin theta sin phi. R sin theta constant, del phi cos phi is minus sin phi. So u is finished. Next we consider v. V equal to v means r sin theta sin phi. So del v del r del r sin theta sin phi, this is sin theta sin phi. Del v del theta, this equal to del theta v means r sin theta sin phi, and this is r cos theta sin phi. We differentiate partially with respect to theta, sin theta means cos theta, and others remain same. Del v del phi del phi v means r sin theta sin phi. So r sin theta remains same, del phi sin phi means cos phi. We get these are the del v del r, del v del theta, del v del phi. Next we find z. W equal to given r cos theta, del w del r del r r cos theta, del r 1, we get cos theta, del w del theta del theta r cos theta, this is minus r sin theta. Del theta cos theta means minus sin theta. Del w del phi r cos theta, we differentiate partially with respect to phi, theta is constant, so this is 0. So we get all of this. Now our requirement is now del del u v w del r theta phi. So what we get? This will be by definition of Jacobian del u del r del u del theta del u del phi del v del r del v del theta del v del phi del w del r del w del theta del w del phi. So this is by definition of Jacobian. We can write this one. Putting the respective values, del u del r, this is sin theta cos phi, sin theta cos phi, and del u del theta, then we get r cos theta cos phi, del u del phi, then this is minus r sin theta sin phi. We get this r sin theta sin phi. Next, del v del r sin theta sin phi, sin theta sin phi, del v del theta, this one r cos theta sin phi, r cos theta sin phi, and del v del phi, r sin theta cos phi, r sin theta cos phi. We get this. Now last one, del w del r cos theta and del w del theta minus r sin theta, and this one 0 we get. Now from this column r common, from this column r sin theta common, then we taking r sin theta common, we get sin theta cos phi, this is sin theta sin phi, and this one cos theta, and here r common, we get cos theta cos phi, cos theta sin phi, and minus sin theta we get. And the last one r sin theta common, minus sin phi, this is cos phi, and this one 0. Now we expand this, r square sin theta we get, and if we expand this determinant, first we consider sin theta cos phi, sin theta cos phi, then this cancel, this into this into this, so this into this is 0 plus this is sin theta cos phi, this one we get minus cos theta cos phi, then this column cancel, this row cancel, this into this 0 minus cos theta cos phi, plus last one minus sin phi. If we taking minus sin phi, then this will be this cancel, this into this minus this into this, so minus sin square sin phi minus sin square theta sin phi minus cos square theta cos sin phi minus cos square theta sin phi. We get this one. Now r square sin theta, this is sin square theta cos square phi plus cos square theta cos square phi. We get this, and from this minus sin phi common, and this minus is plus sin phi into sin phi. We get sin square theta plus cos square theta. We get this. Sin phi common, and minus also common, minus minus plus sin square theta cos square theta we get. And this is r square sin theta, and here from these two cos square phi common, we get sin square theta plus cos square theta, and here we get sin square phi, and this is 1, and r square sin theta cos square phi, this is 1 plus sin square phi. So ultimately we get r square sin theta cos square phi plus sin square phi. This is r square sin theta, this one 1 r square sin theta. We get this. This one we get. Finally, I want to write this del UVW del r theta phi. This value we get r square sin theta. Now our requirement del xyz by del r theta phi, this equal to del xyz del UVW into del UVW del r theta phi. This is by property 2. Second property, del xy del uv, this means 1 by 4, and this value just we get r square sin theta. So 1 by 4 r square sin theta. So we get finally this, and this is our final answer. क्या मस्ती result. This is nice result, very easy, very simple, but solution is some lengthy. So I hope you are all enjoying with me. Without enjoying, mathematics is difficult. With enjoying, mathematics is easy. Just main medicine is practice. With practice, these are very easy, very simple. But without practice, mathematics is danger. So this is not danger because I am here. So if you are enjoying, then please like this video. If you are new in my channel, please subscribe my channel and click the bell icon. Thank you.